Hello and welcome everybody to our second webinar of PVsyst this week, where we will present you our latest developments that have been ongoing and have been published. So my name is Bruno Wittmann, and with me is Oriane Canes, and we will be guiding you through this presentation, which will cover several topics. So the outline of the webinar today is that we will first show you the major features that were introduced with PVsyst 8.1 that was published months ago, namely the weather data import wizard, the new weather data import wizard, and the big new feature, the sub-hourly simulation that's not possible with PVsyst. Then we will show you quickly also the novelties for PVsyst CLI, the command line interface of PVsyst. Maybe some of you know that already. And finally, we will make a very short presentation of the new product, which is called PVsyst Basic. And then at the end, we'll have a question and answer session. If you have questions during our presentations, please submit them in the respective tab. There's a special tab for questions and answers in the Zoom session. And there's also a separate chat where all the participants can chat together, but please, your questions, put them in the question part of the webinar. And I would also like to remind you that all the interactions should be only in English. This is our communication language for today. So please write your questions in English so that we can answer them. Okay, and with this, we will start right ahead with our first part, which is PVsyst 8.1. And I pass over to Oriane, please. Oriane.
Thank you, Bruno, for the introduction. Hello, everyone. I'll start by presenting the new PVsyst feature for weather import. Since we now allow sub-hourly simulation, you of course need a source of sub-hourly weather data. So currently in PVsyst 8.1, there are two different ways to get sub-hourly weather data. The first option is to use the Meteonorm 9.0 new DLL that allows you for synthesizing sub-hourly weather data. And the second option is to import a custom file. So I will exit these slides, thank you, and show you directly what things look like in the software. And then here, let me just highlight my pointer. Here you go. So we are going to have a look at the database section of PVsyst. So the first option, to use the Meteonorm DLL, you have to go to create a new geographical site here. From this window that hasn't changed, I go on New, and then I will choose a location of my choice somewhere. Let's go far today. Let's go, I don't know, here. Accept the selected point. And here on this page that shows me the location of my site, I can have in this box the choice of weather source. And now with the new Meteonorm, I can choose to either import hourly data or minute data. So if I select on minute, I will get a 1 minute time step weather file created. So when I import here the data from the Meteonorm DLL, in the background, your weather file is already being processed, and the monthly averages get copied to your site location here. If I click on OK, I will be first prompted to save the site. The site has been saved. And now I get a second message asking me if I want to save the sub-hourly data file. So yes, here I want to save it. I'll keep the default name, click on save, OK. And that's it. I have my weather file. If I want to look at it, I go to this weather data tables and graph button here. It will open the window to inspect new weather files. This is the last file created. It says Meteonorm DLL here. And you can see here the time step 1 minute. If I look at the graph, we now have the sub-hourly option here. And I can browse through my days to check what sort of data I have created. So that's really one of the simplest way to get sub-hourly data. Now the Meteonom DLL is also available through the synthetic data generation option. This allows you to call the same DLL, but for any monthly site you might have. And here in the time step, again, I can choose hour or minute, and if you choose minute, it will generate a similar kind of file of 1 minute data. Now, the second option, of course, is to import your own data or the data from any provider you want that is in a CSV format. So for this, I will use the custom import file. So this feature existed before in PVsyst, but the organization of the windows has been changed. So the structure is the same, the principle remains the same, but the design is different. So in the first step, I will select my CSV file to import. It opens a window. I select my file, up, done. And then I will need what we call a MEF file. So it's a format file that tells PVsyst which column of your CSV to import and what data is where. So I can either create a new file here or select an existing one. Here I will start from an existing format file. And on this page already, I can display my CSV file here. Let me move my windows up. Here you go. I can already display my file and, for example, select the separator. So here, clearly, my file has a semicolon, so I'll stick with this to be able to import it. So in the next step, I have to select the geographical site for my data. That's important for all the calculation of the sun position for different aspects of the import. Again, you can either create a new site or import something that exists in my database, which I have prepared here. So maybe not Antarctica, but just the webinar file. Here you go. So I've just loaded my site. It displays the information of the location. I can click on Next. And here, really, that's the main page where I'm defining what's inside my MEF file. So again, if I wish, I can open my source file to see what's in it. The first step of the import is really to choose the time step of your file. So here in my file, if I look at my minute column, I see I definitely have a 5-minute timestamp, so that is correct. I have to define also the number of header to be skipped. Then on the next tab, on the date tab, I'm going to define everything relating to the date. So here my dates are present in the file. I can specify the date format that is in different columns here. And there are other parameters you can tweak depending on your needs. For example, is there daylight saving in your input file? Then I can move on to the variable mapping tab, where I indicate what variable is in which column of my CSV file. So here I indicated individual columns for the components of the date. And I can select different variable to import that are present in my file. So here I'm importing global horizontal irradiance, diffuse horizontal irradiance, temperature, wind, and humidity. And if I want to check that the columns selected are correct, I can go to my file, and here, this is the name of a PVsys column selected, and I can check that it matches what I have in my file. All right. So while we're talking, PVsys has already converted my file in the background, but it's telling me here there's a lot of messages that were generated during the import, so I should definitely check what happened. And for this, I'll open the weather data table and graph. And that's what I get. So here I only have 1 point of data, but that's normal. My example file is only 1 month of data, so I'm not concerned by this. But I do have a message here saying there's something wrong with my relative humidity. And if I want to learn more, I can open this new tab called Generation Log that will reprint all the info, warning, and error messages that are generating during the import. And here, clearly, there's something happening with my humidity. it tells me that the range is wrong and I should check the unit. So if I go back here, I have defined my humidity as a ratio. But if I look at the values here, like 81, that's clearly a percentage. So I will just go back here and change the unit of humidity. And PVsys automatically processes my file again. And now it's much, much better. My message here is green. I do still have one warning in my generation log. It says that I'm missing a few lines of files. And if I really read through all the log, I can see that it's really like the end of a day. I might have a few hours missing. I can check that in either the table or the graph. I'll have a look at the sub-hourly data here and see that there are no other issues. The irradiance looks good, but if I go to my last day, indeed, I can see that I'm missing about 2 hours of irradiance. So what happened here is that I truncated my file a bit too early, and I'm just missing these 2 hours. If you ever have irradiance missing in your global irradiance missing in your data file, it will be displayed like this, and this will be simulated as 0 irradiance for these hours. And finally, maybe one last check I might want to do is check the time shift. So here I have almost no time shift detected by PVsyst, but I can still check if that is correct in my graphs below. So I can open, for example, the monthly best clear days and check if my black curve representing my radiance matches the blue curve, which is the expected clear sky distribution for my location. So here, I guess it's not exactly centered, and I could check if there's any fine-tuning to be done with the hourly KT morning-afternoon plot. So the idea of this plot is just to have the same clearness index in the morning and the afternoon. And with this bar here, I can finally adjust the time shift in order to have the same trends in the morning and the afternoon. So I think that's really the best I can do. And when I close this window, this will automatically apply the time shift to my data. I will apply it. If I go back to my date tab here, you can see it's been also saved in the MEF file. And now my file is really absolutely perfect. And I will close this and go to the next button to simply save it. I will first save the format file that already exists. I'll override it. And then I have the option to save the weather file itself that will be used in a simulation. So I'll save the default name, override it. Yes. And really, that's the end of the process. So let me come back quickly to the presentation. So that was mostly it for the weather data import. In future plans, there's 2 upgrades that we are planning to implement. Right now, the custom import file is still limited to a maximum of 1 year of data, but we wish to increase it so that you can generate 7 met file with a very long CSV of multiple years. And then in a second time, we will also update the known weather data import to be able to import sub-hourly data there as well. Currently, the known format is still only for hourly data import. And with this, that's the end of my part on weather import. So Bruno, the floor is yours.
Thank you, Oriane, for this nice presentation. So let's now see what we can do in terms of simulations with this sub-hourly data. So we adapted PVsys to be able to run now simulations on sub-hourly steps, and the steps can go down to 1 minute steps. That's a low step, but there are also all intermediate steps between 1 minute and 1 hour, which fit with multiple integers into 1 hour, can be used. For example, the weather data file that we just created with 5 minutes can be simulated in 5-minute steps. For this to work properly in PVsyst, we had to adapt several of our physical models. The first one was direct diffuse decomposition. So if during the weather data import there's only GHI available, or only POA irradiance, so no separate diffuse measurement. There are models which can decompose this between direct and diffuse parts, and we need that for the simulation to do correctly the shadings and the IAM simulations. So this had to be adapted because the hourly models, when used just like this, were creating biases in the results that had to be removed. And a similar thing happened also in the Paris transposition model, so the model that goes from the horizontal irradiance to the tilted irradiance. If you use the current model that has been published, you will get biases if you do it with 1 minute steps. And again, this we fixed in order to have a good simulation also for 1 minute steps, a good transposition for 1 minute steps. And finally, also the thermal model of the PV modules needed to be adapted. If you do an hourly simulation, you can use a steady state model that just uses the average temperature of a PV module during the hour. Basically, it follows instantaneously the irradiance changes. But if you go down to sub-hourly steps, and especially if you reach the minute, it's important to take into account the thermal inertia of your PV modules, so they lag slightly behind the changes of irradiance. This you see here on the right side, the plots of our new thermal model that is now also adapted to sub-hourly steps. All these studies that we did and all the adaptations have been partially published already and will be published in upcoming workshops and conferences. So as you see also on the bottom slide, going from hourly to 1 minute steps is really important. If you do, for example, a simulation with a lot of clipping, you see that the detail that you have if you do the minute scale simulation gets slightly lost if you do hourly steps. We had already correction models for the hourly simulations. You will see that later in the example that I'll be giving, but it's certainly more precise to run in minute steps if you want to get the full detail out of it. The last thing that needed to be adapted before we could really run nicely the sub-hourly simulations was also the time series parameters that you can import into a variant. For example, the load profile, if you have self-consumption or storage in your system, you can import time series as load profile, and also this needed to be adapted to sub-hourly steps to make sure that the time steps that you have in your import match the time steps in the weather file or are matched before we run the simulation. So now, after this introduction, I will show you a small example with PVsyst of a sub-hourly simulation that we will do with the weather data file that Oriane has just generated. So I will go to Project and start a new grid-connected project. It is completely empty. When I select my site, PVsyst will put me already on the last site that was generated. So it's the Webinare example from Oriane. I will say OK, and PVsyst also finds directly the weather data file that's associated to it. So you see that it was generated for exactly this location and that it's in 5-minute steps. So I will save my project. I will call it Webinare example. And then we can go on by defining a system that we want to simulate. So I will not create a system from scratch, but I will import a variant that I have prepared already. So I will go to import and select here from my example projects a variant with trackers on terrain. So these are horizontal axis trackers, which are on a hill. So they're following a topography. And we will run this, we will use this for our example. So as you see now, here above the Run Simulation button, we have two options. We can run the simulation in hourly steps or in sub-hourly steps. And the sub-hourly steps will always follow the time steps that are found in the data, in the weather data. So I just need to click Run Simulation, this selection, and basically I will get my simulation in 5-minute steps. Since we are simulating only 1 month, it goes rather fast. We chose this for this webinar so that the simulation would not take too much time. Of course, if you simulate a full year, it will take correspondingly longer. And if you go down to 1-minute time steps, you will also increase the simulation time. But you see here, we have our results. And if I look in the hourly graphs, for example, for my results, I can choose the energy injected to the grid and look at the sub-hourly values. For this, let me go down here. Energy injected into the grid. And I have now here in my selection the possibility to show the sub-hourly results. And if I do that, you see that I will increase a little bit the scale, that my simulation is done in the sub-hourly steps, and I have the full detail of my results. If you want to analyze these results, you can also export this to output files. So the standard export of output files in PVsyst works also with the sub-hourly values, and you can get your results in CSV files that you later process. Now, since I said I will first save this quickly, so these are 5-minute results. Since a 1-minute simulation over a full year, or the sub-hourly simulation in general, can potentially take a lot of time, there are ways to make the work more efficient instead of running all the time the sub-hourly simulations. You have the choice to run an hourly simulation on the same data. You don't need to create a new weather data file. PVsyst will just average over the hourly values of the weather data and launch a classical hourly simulation. This is good for early design stages where you are just adjusting the main parameters of your system. You can run the simulation. You will see it goes much faster, yeah, than the sub-hourly simulations. And I have my results. I can also save those. Yes, and I will call it hourly results and save it as new. And with this, I can go through a cycle of design choices and optimizations which run quickly before I go to the detail where I run in sub-hourly simulations in my 5-minute steps for the final simulations, or if I need to look at an aspect which needs more detail of simulation. For example, the clipping, which is important in sub-hourly irradiance peaks. There, of course, it's necessary to understand the details to run in sub-hourly steps, but also there, instead of running for the full year, in advanced simulations, you have the option to run over only a limited period of time. And this is very helpful because you can, for example, run only over the summer period where you have true clipping to understand how the clipping is impacting your results. And then once this is understood, you can do one final simulation over the full year. So also in these advanced simulations, you have here down next to the simulation button, the option to choose the hourly or the sub-hourly simulation. And now if we look at the results, this was an example with heavy clipping. So if I look at the results of the hourly simulation in my report, I can compare that to the sub-hourly simulations, and we will do that quickly. I open the report and compare it with my 5-minute results. It takes a few seconds for the report to be generated, but we will have it soon on the screen. So on the left side, we have the hourly simulation. On the right side, we have the 5-minute steps. You see that the results are slightly differing, but the differences are small. Yeah, if you look at the PR ratio, it's really similar. So for this particular simulation, already the hourly simulation gets very similar results. This was 1 month in summer with heavy clipping, and we can analyze the differences in the loss diagram here. And I will not run through all the details. I will just tell you that the main differences between the hourly and the sub-hourly simulation are indeed the transposition, where we have to adapt the minute model, and then which is more precise for if you run in 5 minutes. Also, the diffuse contribution of the bifacial part is slightly different. And for the clipping, you see on the left side, this is the hourly simulation with the sub-hourly correction of clipping model, which works for hourly files, but it's only an approximation, which calculated 0.87% of sub-hourly clipping correction. And if you compare that to the detailed results with the 5-minute simulation, you see that the result is quite similar, but you gain a little bit in precision if you run in 5 minutes. So the correction for the hourly part overestimated a little bit the clipping losses in this case. And with this, I would like to finish my part of the sub-hourly simulation, just saying that it's possible. I come back to my slide. It's possible now to run in sub-hourly steps down to 1 minute with PVsyst. In the future, instead of giving only the option of choosing between hourly and the sub-hourly steps in the weather data file, we will also include the possibility to run intermediate steps. If you have, for example, 1 minute weather data, it will be possible to run the simulation in 10 minutes or 15-minute steps, not only in hourly steps and 1 minute steps. This will also save you time and give you already some level of precision if you use 10 minutes, for example, instead of 1 hour steps. This will be coming in the updates of version 8.1 over the year. And with this, I will finish and we'll come to the next part of our presentation, which is PVsyst command line interface, PVsyst CLI. So this is not a new product. It was already released with PVsyst 8.0, the command line interface. And the idea behind this is the following. If you have the desktop application of PVsyst and you are optimizing your design, this is very good. You can really look at the details, specify details, run a simulation, see the impact that it had, and work like this. However, once you have more or less finished your design and you want to run multiple simulations, let's say with different weather data files, or you have a running system and you are monitoring and you are regularly getting new weather data and you want to run PVsyst simulations on that. Or if you want to explore different locations for your system, which is fixed, then of course this can become tedious. Yeah, you can lose a lot of time just running multiple simulations which are quite similar. And for this, PVsyst command line interface comes in handy, because this will allow you to automatize the running of PVsyst simulations. The idea is that you have the PVsyst simulation engine, you have a workspace with projects and variants that you have prepared, but you can run automatic processes, automatic simulations on that. And in principle, there are a few options that are possible with this. You can change, first of all, you can run simulations. So you choose a project, a variant, and you run the simulations. You can create output files with the simulation results, and you can specify this as parameters on your command line. You can change the weather data file, so you can run the same simulation with different weather input. Now with PVsyst 8.1, it's also possible to create new sites with the command line interface. And this opens the way to do automatic prospection with PVsyst. And there is also the possibility to use the batch mode of PVsyst with the command line interface. So in principle, for those of you who know the batch mode, you can define in so-called batch parameter files, which are CSV files, different parameters that you want to change and make parametric scans, for example, sensitivity scans on different parameters. And you can prepare now with your own script these batch parameter files, and instead of feeding them in manually into PVsyst desktop application, you can run the batch mode from PVsyst command line interface, from PVsyst CLI. And this gives you a lot of power. And the idea, of course, is not to run the commands by hand, like you see it here in this example, but of course you prepare your own scripts, or you have an automated way to create scripts or to generate commands that launches this. And this I will show you in a very quick example. What you can do with that, we just put together very, very fast a way to do prospecting with PVsyst command line interface. The idea is that you have an application where you can choose a location, and you have an API call to retrieve weather data. In our case, in our example, it will be the PVGIS database. Then we use the command line interface of PVsyst CLI to create a site from that. And once we have the site, we use CLI to run a simulation of standard PV systems on that and look at the results. So without further ado, I will show you this example. It is really very simple. It's not very sophisticated, but it demonstrates already how powerful it is. So it's a web-based application. It runs in a web navigator. You see here, I can click somewhere on my map. Let's choose maybe a location in Portugal. I click on it, and this retrieves just the location. The altitude does not work yet very well, so I will introduce a value by hand. I have my workspace of PVsyst adapted to it and a list of projects which are inside. Right now I have only one project, default project, but in this project I have 3 variants, 2 fixed tilt and one facade. So I will choose the fixed tilt 10 degrees with 20 rows as my example that I want to run. And now if I click on run simulation, what will happen is that there's a script that retrieves from PVGIS API the weather data, the monthly weather data. Then there is a call to PVsyst CLI that creates the site. Then there is a call that will create the weather data, import the weather data that corresponds to this site. And finally, there will be a call to the command line interface that runs the simulation. So I will click on run simulation, and you see here the progress, fetching the weather, creating the site, and the last step is running the simulation, which will take a few seconds. And all this uses really the PVsyst engine. So there's a true PVsyst simulation. I had to create, of course, the variant in advance for this specific example, but all the rest is now automatic. And you see, I have my simulation results. I can look at different variables, e-grid or performance ratio for this specific site with PVGIS data. I can display values, or I can display the tables. Everything that the PVsyst allows to output in CSV files can be now retrieved and be implemented in your application. So, as I said, this is not extremely sophisticated, but you see that with little the potential of the command line interface that allows you to automatize a lot of work for the PVsyst simulations. If you are interested in this, I recommend you to maybe try it out and see if you have use cases for that. This was one use case, but for example, monitoring an existing PV installation is another use case where this automatization comes in very handy. And we'll be developing and adding further features to this, also based on the feedback we get from our users. So if you have an idea of something you want to do with this and it's not yet possible, let us know, and we will see if that can be accommodated in our roadmap. And with this, I finished the CLI part that I wanted to present. And we come to the next part, the third part of our webinar, which is about PVsyst Basic. And I hand over again to Oriane, please.
Thank you. So now we're going to switch to a completely different product that is PVsyst Basic. So that's brand new. We released it a few weeks ago. And it's for a different use case. So if you want to simulate a simple isolated system, PVsyst itself can be really complex to use. And that's why we have developed PVsyst Basic for that sort of use case. So PVsyst Basic is really dedicated to the designing of small isolated systems that have no connection to the grid. And the tool is meant to be used more easily and does not require extended PV simulation training. Currently, you can only simulate solar pumping installations with PVsyst Basic, but in a second time, we plan to also have the ability to simulate simple standalone systems. And you can see here on this slide the interface. It looks rather different from PVsyst, but in the background, it's actually the same computation engine. The main difference being that in PVsyst Basic, you have access to less parameters. You can do less tweaking so that it's just simpler to use. So now let me show you the software itself, and we'll walk through a little demonstration itself. So this is the welcome page of PVsyst Basic. It should look familiar to you because it looks a bit like PVsyst. Here you have access to databases, documentation, and then of course in the main window we have projects. So right now I can either create a new pumping project or use a recent project, and that's what I will be using. I'll be presenting to you one of our demo projects. So this has been already fully defined. When I open it, I arrive at the last page, but let's walk through the entire process and go back from the beginning. So when you start your new pumping project with PVsyst Basic, you first need to choose the site where you want to have your project. So that's already been defined here. We are in Dakar in Senegal. And there are two system types you can simulate, either pumping from a deep well shown on the graph here or from a river. Here in this example, we'll stick with the deep well situation. Now, in the next step, and you can see we'll walk through all the steps that are outlined here on the left. On the next step, I will define my water needs. So on the left here, I have a box where I can specify how many meter cubes of water I need per day, and I can input these variables either as a yearly average or seasonal or even monthly values. And on the right here, I'll specify the dimension of my tank to store my water. Once this is done, I can click on Next here. And in the next step, I have to define the hydraulic characteristic of my location. So this is really specifying the behavior of the groundwater on our site. That's something that has to be measured first. So for example, what is the static level of my groundwater, the dynamic level, the diameter of my borehole, and also I have to input some information about the pipes I'll be using to define properly the flow rates and that sort of thing. When this is all done, I can click on Next again, and then I'll arrive at the definition of my water pump. And here you can see you actually have access to all the components that are already present in PVsyst. Really, all the databases are going to be the same for different components. And here what is neat with PVsyst Basic is that depending on the parameters I've defined in the previous step, it will recommend reasonable choices for my pump. So that's already chosen. I'll click on the next step. And in the next step here, I will define the PV array I'm going to build to power my water pump. So again, access to all the PVsyst database. I've chosen my PV module. Here, it is a simple scenario. I only have one PV array, and I can choose how many modules I have in series and how many strings. And here on the bottom, I have to choose the pump controller that will connect my PV panels to my pump. Once this is done, I go to the next step, which is the panel orientation. Again, I can choose here the tilt, and it shows you really with a visual what's happening. I'll try my simulation with a rather flat orientation, and I can also choose the azimuth here. One thing I must mention is that PVsyst Basic is rather simple, and one thing that is not included is the 3D shading scene. Here we do not have any simulation of shadings. And finally, I have the opportunity, if I want to tweak a bit the detailed losses for my system. So that is the thermal loss for my system and the ohmic losses due to my wiring. So here, I'll just leave the default values. And that brings me to the last page where I can run my simulation. It says here, I've defined everything I can run. PVsyst Basic only simulates in hourly steps, and it goes extremely fast. It's already done with a simulation. Here I see the main result of my setup, and I see my dimensions seem reasonably good compared to my water needs. If I want to look into more details, I still have access to a PVsyst-like report. It's very similar to what you might know from PVsyst. It just has a few, maybe let me put this bigger. It has just a few less pages, but we still have detailed losses and general monthly results. Yes, we'll close the report. So that's it for the simulation itself. I will not save my project here. And one last point I would like to showcase to you is the technical tools that are available here. So if I open them, this gives you access to a set of different tools, so either a bit more general information to understand better the simulation output, but also a few tools to help you size your project or interpret some results. So for example, a neat little tool that we have is the pumping test tool that helps you define the flow rate you want to use for your setup once you have done a pumping test. So basically, when you drill a borehole to install a well, there is a test you have to run, pumping at a given flow rate at different depth to check how the dynamic water level behaves. So if you do such a test, you can input values in our table here. It will display the result of your test on a graph here, so what you measured as water level and the flow rate. And from what you obtain, it will automatically recommend you a flow rate to use at your specific location. So that's just one example, but feel free to explore all the different tools that are available in there. And that brings me to the end of the demonstration of PVsyst Basic. I'll put back my slides. That's not the slides, but that's what I wanted anyways. I wanted to finish with, of course, our webpage with all our different products. So what we've presented today are 3 different products. You do need a different license for each of them, but all of them are available to download. And you have 1 month trial for PVsyst Basic, 1 month for PVsyst itself, and PVsyst CLI has a slightly different trial version, but they are all available for you to test. And when it comes to PVsyst Basic, if you like it and want to continue using it, we try to make it as affordable as possible. And right now, the license is only $32 US. So that's it on my side, Bruno.
Yeah, thank you very much, Oriane, for this nice presentation of PVsyst Basic. We now come to the end of the part of our presentation, and we move over to questions and answers. I remind you that the questions should be in English and that there's a special tab in Zoom to ask your questions. We have a team in the background who has been answering already and moderating these questions. They will put up the most asked questions on our screen, and we'll try to answer them. In a neighboring room, there's also Eric and Izir with us who will help us answering these questions. But if any of your question is not answered today, I remind you that this webinar is being recorded. And when we will publish the video, we'll also publish all the answers to the questions, and the questions that were not answered today, we'll collect them in a separate document. We make written answers, or maybe we'll also make a small video together with that, and will be published together with the video of the webinar. So even if your question has not been answered today, once the video is published, look it up. We will try to put in answers to all the questions that come up in the tab today. So, our first question here, and maybe is the following. Could we also import sub-hourly metadata from a custom file using the import as known format function? Let's say I have a custom metadata file in the standard PVsyst formats. So this is to Eric. Please, Eric, can you answer that question?
Yeah, sure. It is currently not possible to import sub-hourly data. Excuse me. Sub-hourly data, with a non-format functionality in PVsys. However, what it is possible to do is use, the assistant to import sub-hourly data. And this is done, through, the creation of a MEF file. MEF file, being a file that, will describe the format of the file. And this would be, possible, to apply it, to different file, of the same type, through, the assistant. So, it's not possible, with a known format, however, possible, with the assistant and using, a custom format.
Okay, the next question is, could we use sub-hourly clipping correction when importing Meteonorm 1-minute data? Maybe Oriane, you can answer that.
Yes, I'll take that question. The answer is yes, absolutely. So right now, if you have really any kind of sub-hourly met file, when you run the hourly simulation, as Bruno showed, the clipping correction is automatically applied. So indeed, having a 1-minute Meteonorm file, or just in general 1-minute file, is really the optimal scenario to use that clipping correction, but it will be computed for any time step.
And let me add to this. I mean, if you really run a 1-minute simulation, you don't need to do that correction anymore. Yeah, the simulation will take care of modeling correctly the irradiance peaks and these clipping losses that are specific for these irradiance peaks. Yeah, so if you run sub-hourly simulations, you don't need any correction. Yeah, it's already good.
Maybe I'll read the next question. Could we export simulation results in sub-hourly granularity also?
Yes, that is possible. So right now, if you create an output file, a CSV output file, during the simulation and you run the sub-hourly simulation, it will create sub-hourly values and then fill them with exactly the same time step as the simulation is running. We have a small issue right now with version 8.12, where some of the variables are not exported correctly. So some of the columns are empty or have non-numerical values, but we are fixing that, and with version 8.13, this problem will be solved.
Then another question for you, Bruno. With 1-minute Meteonorm dataset, could we simulate in, let's say, 10 minutes or 15-minute time steps?
So right now, this is not possible. You can only choose between 1 minute and 1 hour. But as I said before, the idea is to put this feature in and allow you to quickly choose an intermediate time step that is compatible with your basic data set. Of course, if you have a 2-minute data set, you cannot run in 3-minute steps. Yeah, but it has to be compatible. But yes, we plan to do that to allow also for intermediate steps.
Thank you. Then we have a bit more complex question about the simulation details. So what time step is internally used for the thermal modeling and inverter efficiency calculations? And can this improved resolution better represent transient cloud events, inverter behavior, PPC ramp rate, response in utility scale PV plants?
So indeed, the time step in the simulation will be the same, and the internal models, also the thermal models, will use the time step that's in the simulation. We have a transient model, which basically means that we have a transient model for the temperature calculation. So this will have a sort of memory backwards, and the memory from the previous time steps will flow into the calculation of the current time step. And the time window that we are considering depends on the thermal inertia of the PV modules. It can go up to 1 hour even. So this is in there. Now for the inverter behavior, of course, the clipping behavior will be better represented if you do a sub-hourly simulation because you go in sub-hourly steps. But we have not yet adapted any MPPT tracking, for example, or ramping effects to take into account a slightly different behavior of the inverters, which is specific to those ramps. This is not yet the case. We are studying, though, these cases and try to understand where it's important to model this to get an accurate simulation result in the end.
Thank you. One last question for you. How big is the impact on the processing time and overall load of the program with a minute time step simulation?
So this is a straightforward answer. It's just proportional to the number of steps. So right now, it's just that you have, if you have compare an hour simulation with a 1 minute simulation, you have 60 times more time steps, and this will make your simulation on average 60 times longer. There's a little bit overhead in the simulation, but on that scale, that is negligible. This is why I said before that it's good to look for efficient ways to have a quick simulation turnover once you are still in the phase of first design, where you don't need all that detail, or when you don't want to understand the clipping, you can run in longer or with the sub-hourly clipping corrections, but or just over summertime, over a restricted period of time. But right now, it's really just proportional to the number of steps. But of course, now that it's possible to run, before this was not really much of an issue in hourly simulations because it was pretty fast to run hourly simulations. But now, since this becomes an issue with these sub-hourly steps, we are looking more and more into ways to optimize the processing time and the CPU speed and make use of multiple cores to make also the simulation times of these more extreme cases, well, of 1 year, 1 minute with a lot of shadings, make that in an acceptable simulation time. So we are working on improving the efficiency of the simulation to make this better.
Thank you. Now maybe we'll move to a few questions about PVsyst CLI. So maybe I'll ask easier in the next room.
Yes.
What is the advantage of using PVsyst CLI to run simulations versus PVsyst?
Oh, good question. Yeah, the first advantage is that you can run multiple simulation without any user interaction. So you are able to quickly run a lot of simulations. If you will do it in PVsyst, you will need to open the project, select the variant, run the simulation, and then print the report. In PVsyst CLI, you can do all of this command in one command line. So setting your project variant, running the simulation, and generating the report. So it will be much faster to use PVsyst CLI if you have a lot of simulation to run, for example, in different places, or if you want to adjust a simple parameter, you can do it through PVsyst CLI very quickly.
Okay, there is another question related to PVsyst CLI, which is asking, a user is asking, is there a limit in number of calls we can perform with PVsyst CLI? Can we install PVsyst CLI on a Windows server?
Yes. So yes, you can install PVsyst CLI in Windows Server in order to take advantage of the power memory of this kind of systems. And no, there is no limit in the calls you can do with PVsyst CLI. As soon as you have the license, you can run as many simulation as you want.
Okay. I see that there are also questions concerning PVsys Basic. So one question reads, does PVsys Basic need a specific license to use, or can I enter my standard PVsys license number? Eric, maybe you can answer to that.
Yeah, sure. PVsys Basic is a different product as PVsys, so therefore you need specific license. You can find all the information on our website, and just for information, a PVsys Basic license costs 25 Swiss franc currently.
Yes, maybe let me add to that. It is really a rather symbolic prize because it's aimed at situations and at regions where people have difficulties with access to water and to electricity. And the idea of PVsystBasic Basic is to help in those situations.
Maybe another question for you, Eric, still about PVsyst Basic. Is PVsyst 8 different from PVsyst CLI and PVsyst Basic? I thought they were all included in PVsyst 8.
There are different products. So different products, means, different license. And they live, separate lives, let's say.
Yes, but the installer, I think, is the same for PVsyst 8.1 and PVsyst CLI. I think you download the same, but you just need a different key to activate PVsyst CLI, and which comes with a different license. Is that correct?
Can you confirm, Isia?
Yes, right. Yeah, PVsyst CLI is already included in the installation of PVsyst, but in order to use it, you will need a specific license. You will need the PVsyst CLI license.
Okay. Maybe one more question concerning PVsyst command line interface. Is a demo mode available for PVsyst CLI for one to understand, and then subscription can be taken? Yeah. So can you try it before you really buy a license?
Yeah, sure, of course. So the trial period includes a 2-month use. You can use the product during 2 months, and you are limited to 120 calls. So you have 60 days and 120 calls.
Okay. Thank you very much, Isir, for that. Maybe we have can take one last question because the time is coming to an end. Also concerning PVsys CLI, can a plant configuration be run using multiple SIT files, so multiple site files in PVsys or CLI?
Yes, as you have shown it in your presentation, we can select different sites with the new version of PVsys CLI in 8.1. So you can generate your seed files and also use them for running simulation. So programmatically, you will be able, for example, to generate seed files for a lot of location and then use this seed file to run your simulations in PVsys CLI.
Okay, thank you very much for this answer. We are coming to an end. The time is over. I thank all the participants who joined in for your interest in PVsys. I hope this was interesting to you. I hope you enjoy working with PVsys. If you have any questions, you can also contact our support line, of course. And I remind you that this webinar has been recorded. There will be a video being published on YouTube. And together with that, you will also have all the answers to the questions that were left unanswered today. And with that, I thank all my team also, which was in the background working for this webinar to run smoothly. I thank the participants, Eric and Isir in the next room, and Oriane, who is next to me. And I wish you all a good day still. And
see you next time.
see you next time.
Goodbye.
See you next time. Bye.
Bye-bye.